I'm Leanne Yenny, and I am going to talk to you about double number lines and tape diagrams. This comes from the Proportional Reasoning Standards of the Common Core, grade 6. You can see that I've documented that here. The standard reads to use ratios and rate reasoning to solve real-world and mathematical problems by reasoning about tables of equivalent ratios, and this is where you see this in the Common Core. For example, tape diagrams, double number lines, or equations. So I'm just going to specifically talk about tape diagrams and double number lines in this little video segment. So first of all, tape diagrams, as defined in the Common Core, are drawings that look like a segment of tape. They're used to illustrate number relationships, and this isn't a new idea to you. If it sounds like a new idea, I'm guessing that it probably isn't. It's just that maybe they haven't been known to you as tape diagrams, because they're also known as strip diagrams, bar models or graphs, fraction strips, or length models. The other thing I would say about this is that tape diagrams are extensively used in the Singapore math curriculum and also in many Japanese curricular materials. Okay, so that's what we're going to start by, talking about tape diagrams. And what I'm going to do is I'm just going to do 3 examples of tape diagrams that I think will be helpful to understand them. And this first example is focusing just on number. And so in this example, Brian can bench press 15 more pounds than Pat. So you can see that we're just comparing Brian to Pat in this example. If Brian can bench press 305 pounds, how many pounds can Pat lift? So this is a tape diagram. So I have a tape diagram for Brian, and then I'm going to make the tape diagram the same length as I did for Brian for Pat. And I'm showing that Brian can lift 305 pounds, and I know that Pat can lift 15 less than that, so I'm crossing out that 15 chunk, and so of course whatever is left here is what Pat can lift. So I'm able to then just subtract 15 from 305, and I'm left with 290 pounds. The benefit of the tape diagram here is just a visual representation of the comparison of 2 numbers. Okay, so now let's look at tape diagrams in the context of percentages. So I think they can be really helpful in percentage problems, especially the more complicated percentage problems. So in this example, of the 452 vehicles in the MSU parking lot, 25% of them are blue. How many blue vehicles are in the parking lot? And so you can see here I just have one tape diagram. I'm not comparing 2 quantities here. And I know that my 25% is going to have 4 sections if I want to show my tape diagram as 100%. And so all together that would be 452 cars. And so my 1/4 would have to be my 113. And the process that I went through to figure out that 113 is, of course, knowing that my 4 units together equal my 452. And then I just divide my 452 by 4 to get my 113 for each unit. And that's what I'm left with. 1 unit is equal to 113. I think tape diagrams are also useful in talking about ratios. So let's talk about ratios in this next example. In Dr. Lindemann's math class, the ratio of boys to girls is 5 to 2. If there are 35 students in the class, then how many are boys? So again, in this example for tape diagrams, I'm comparing 2 quantities, boys and girls. So I have my boys and my girls, and I know that the ratio is 5 to 2. So I'm going to have 5 units here and to 2 units here for the girls. I know that altogether I have 35 students. So what I'm going to do is I'm going to divide that 35 by the total number of units that I have, which is 7. And I'm left with 5. So then I know that each unit has a value of 5. And if I know that each unit has a value of 5, then I can take my 5 units of 5 and I can multiply them together and get 25 students that are boys. Okay, lastly, we're just going to talk about double number lines. Those are also mentioned, if you remember, in the Common Core standards that I just read. And double number lines are just simply diagrams that are best used when quantities have different units. So I tried to give you an example of that here. And in the nails problem that you'll be doing in the module, you'll also have to use a double number line to look at quantities of different units. So in this example, it took Megan 2 hours to complete 3 pages of math homework. So right here we can see our different units, hours and pages. Assuming that she works at a constant rate, these are great for rate problems as well, and if she works for 8 hours, then how many pages of math homework will she complete? So the first thing that we did is we created 2 number lines and we labeled them. So I have the top number line labeled pages, the bottom number line labeled hours. And I know that it takes her 2 hours to complete 3 pages. So I'm starting here with 2 hours to 3 pages. and then I simply fill in the rest of the intervals. 4 hours to complete 6 pages, 6 hours to complete 9 pages, and 8 hours to complete, this is what we want to know. So I'm simply able to then find the pattern or simply count to see the relationship between pages and hours. And in this case then I can see that it would take me 8 hours to complete 12 pages. The other useful thing with double number lines is then you can use them to find your unit rates. So that's what I'm adding to this here. I can then further divide my intervals here. So my interval between 0 and 2, I can add a 1, which is what our unit rate is how many pages per 1 hour. Per means per 1, of course. So my 1 hour, I would get 1.5 pages of homework completed. Okay, so I hope that that makes sense. And if you have further questions, make sure that you ask the instructor in the module or your mentor for some help. Thanks.